Hello everyone. We will wait 10 seconds. Okay. Do we need the music? Okay, cool. So, hello everyone. How was the after party? Good? Still hangovered? So it was good or not? Okay, great. Nice. Okay, so today I will talk about Kotlin, our favorite language, and to be more specific about how to make your Kotlin codebase happier. My name is Piotr. I'm an Android developer for a couple of years, and I work at Grand Parade on my daily basis, but during the night I'm an GDG organizer, one of them. So yeah, that's it. So today we will talk about syntactic sugars / features. So how many syntactic sugars do you have in your pocket? Can you name them? Don't be shy. Guys, please. I know it's morning, but... So? Just one? The coolest feature of Kotlin? What? Quick question mark. Okay. Okay, cool. So today we will talk about data classes, about sealed classes, and extension functions. Are you happy? Enough. We will not talk about this, sorry. I assume that all of you know about data classes, sealed classes, and extension functions, so I will not be killing you and repeating all the time the same things. So today we will talk about some different things. Of course, I will mention about data classes and other stuff, but not directly. So today, our agenda is standard functions, tuples, destructuring, aliasing, reified inline, and my favorite, delegates. So actually, this is the last slide of my presentation. Now only coding. So I'm really sorry if you are here for slides. Okay. Yeah. Can you see it? Okay, cool. So, okay, firstly we will start about standard functions. So, do you know how many standard functions do we have in Kotlin standard library? A lot. And how many of them are useful? A lot. Okay, so we will talk only about 4 of them. We will talk about let. We will talk about apply, run, also and apply. What is the difference, why we should use them, and how we should use them in a proper way. So the best case for let is to unwrap the optional. This is how people do it. Whoops. So this is how people do it, and most of the people think that this is the only case for this. So do you think that it's true? Okay, yeah. So to make sure that it's not only for this, we should focus ourselves on the signature. So here we have a signature of let. As you can see, we have some fancy generics. It's an extension function, so it's made to be called on something, on some type. And as a block, it has a lambda that takes a receiver, the type of receiver, and returns some value. So probably you can think from this that let can let you map objects. Map function gives you ability to map and iterate. Here you can map the object itself. So for example, we can use it as let, and map it to something. For example, to capitalize. And moreover, because we have here an it, so the value is passed as an argument to lambda, we can go and convert it to lambda reference. But not every time we can do it. Sometimes we have a function let's call it normalize, and as a parameter of this function we will have the string. So here we are normalizing, so we are returning string, and value we will just capitalize. Okay, so in this case we cannot do this, but we are doing normalize it. We need to return. Oh, I did some mistake. Probably. Oh yeah, I had it already. Whoa, I'm hangover. Sorry. Also the return. Maybe I have it. Oh no. Okay, so let me just stop it. Okay, so what we can do here also, because we have it, we can do some transformation of Kotlin. So we can convert to lambda reference. So it's even more clean. Then we can express, and this is how we can map objects to some other objects. And the let is made for this as well. And when you will check the run function, it's almost the same. So what is the difference between let and run? Can someone say it out loud? Yeah. Yeah. So yeah, that's correct. That's a really good answer. So here it's the clue. So here we have an extension scope of t-type. So in the block, we will not be it, so the argument will not be passed, but we will be there as an object. So we can act as we are in the class and call the public methods on the object. So this is a different, it's almost the same, but imagine that you need to run something, but you are in nesting scope, and this is kind of inconvenient in nesting. So if you have a lot of its, you can name them. So with let, you have it, but you can do something else, like put. So we can rename that the argument, and we can be more clear. Also, with approach of having an argument here, we can use the structuring of data classes, but I will talk about this later. So yeah, so now we know what is the difference. And yeah, and we know that let is not only about unwrapping. So let's talk about also. So the also, as the name says it itself, it's about side effects. So if we want to do something on an object and return it, and also do some side effect, this is the perfect function. Of course, we don't like side effects, but yeah, it's not pure functional programming here. So yeah, so we can do also, and also is returning the type already. So as you can see, we can specify it, and it's string. So actually it will be name. But here we can do some side effects. So for example, we can we can do something like this. So also is for side effects. So why we have apply here? Do you know why we have apply in Kotlin standard library? Yes, initialization is and mutating. So, for example, we have a builder, string builder, and we want to mutate it. Of course, we can do append because this class is. We can chain the calls here, but sometimes we cannot do them. So we can use apply to do the same kind of technique like piping, like chaining. So we can move this to apply function and just call it like this. And why we can omit the argument? Why I don't have to put it here? Yes, because I have this, and moreover, I'm an extension of the scope of the type. So this is. So those functions are the basic stuff of Kotlin. So it's easy, but sometimes people are not using them correctly, and also they are arguing about them a lot on the daily basis. That's why I'm talking about this, but it's simple. So let's go to tuples. So tuples are the tuple are type of a pair. In Kotlin we have it. So how we can use it and why it's so useful? So as you can see here, I have a definition of employee, and I have a definition as an enum of contract, and some data time class, just a dummy class to make it more readable. And I have sealed class that encapsulates some access. So I have granted, not granted, and blocked. So I want to do permutation of those two enums. So for every single case of employee, I can get some access when the guy is on some contract. So So how we can do it? So basically, what we can do, we can switch, or when, we can when employee, and then for every case we can do a when on contract. But then, as you can see, we have a lot of cases that are the same, right? So we do not like this kind of code, and even here, yeah, you see, probably you get my point. So what can we do using tuples to make this when more swift? Because in Swift we can put some values in when. Do you have any idea what can we do? Yes, we can put a pair here. We can put a pair here. Employee contract. And then we need to transform, we need to flatten this switch to pairs, right? But we know that we have a really nice syntax for pairs, so we can do it even more clean. So we can do it like this. And this is some kind, it's a little bit swifty, but it has some side effects I will show you later. So it was the good thing, but the better, as I said, we can do it like this. So I'm using pair in when, and then I can just permute over the pair. So I don't have this nesting things. So do you see any drawbacks, like side effects, negative things here in this syntax. No. If you will forget about something, your unit test will tell you. But anything else? Guys. Yeah. So the memory? The memory, yeah. This is one of them. And there is one more. Okay. So one more thing is that we are not case safe. So we can do this. And we can do this and this. So actually Percel, it doesn't work. So we can emulate the Swift switch, but we will have to be really careful about this. And also when we will probably produce access for some big collections and we will iterate it, and we will iterate over it, we will produce a lot of things. Because there is no like object pool for pairs. When we go here, we can see that pair is created. So it's not good. But I wanted to show you the syntax of it, just, it's really fun to play with it. Okay, the next thing, it's about the structuring. So do everyone know what the structuring in Kotlin is? Raise your hand if you know. Okay, half of you. Nice. Okay, so imagine that we have person, and we have some values in person class, 3 of them, name, address, and surname. And we want to produce a full name. So how we can do it? We can do it Java way. So we can just assign the name value to value and the surname value to value, and then we can just produce something like this. It's clean, it's okay, but still, we have some tools, some sugars to make it even more beautiful. So what can we do here? Using the structuring, we can do val. We can copy and paste those things here. And we can do person. Of course, we need to do the address as well. And we can just assign person to it. And it will be the same. It's the same. For me, it's a cleaner solution. But there is one thing that we need to add to person. What do we need in person class to make this compile? Yes. So we will talk about data class. Liar. Yes, we need to put the keyword data class. So why does it work at all? We can check it in our show Kotlin bytecode tool. We can check the bytecode, or we can decompile it to Java. It will be better. So as you can see, the person class, when it's a data class, it has a lot of generated things. And the magic is that the Kotlin compiler generates the component function, component 1, 2, and 3. And this is how the Kotlin, the structuring works. It uses those functions. So that's easy, but someone can say, oh, but I have this address, and probably I'm also assigning an address, but I'm not using it. But yeah, the Kotlin compiler is pretty smart, but sometimes we can tell him, don't generate stuff. So we can just put it a dash, and now it's not generated at all. And yeah, so so it's okay. I will just decompile it to show you that we can actually say something to compiler. As you can see here, only those two values are created. So we don't have it, but we have a check, so that's fine. Okay. And also the structuring works in lambdas. So this is a really nice thing when we have a data class and we want to map those objects, those data objects. We don't have to do it like this. We can just do name, name, and address. And we don't need this at all. And then we can just do it like this. Yeah, just more clean and elegant. So it works in lambdas and it works just here. So it's really nice. So the structuring, do you like it? Nice. So the next thing, it's aliasing. Do you like aliases? Do you use aliasing in Kotlin at all? Type aliases? Yeah. Okay, cool. Do you see any problems with Kotlin type aliases? Okay, nice. I see too. And I don't like them. and I will tell you why. So for example, we have a function print, and as a first argument we have text to print, and as a second a color. But we don't want to mix type here. So the first one is string, and the second one can be string. So it's pretty inconvenient to have this kind of functions. So we want to name the second type as hex color, but we don't want to create any class for this. So we can do type alias for hex color, and it's going to be string, and now our function is more readable, right? It's more verbose. But then some other guy will try to extend your code and will say, oh, I can do extension functions on type aliases. So he will do a function to RGB. And this function will do, I don't know, to string. And do you see any problem with this? Because normally I would think, oh, I did a extension function on type alias type, so it will be visible, so I scoped this function. I don't want to have this function on the scope of string, so that's why I will have it on a scope of hex color. So is it true? Yeah. So then the guy will do a merge request, someone will approve it, and you will end up having this function to RGB on every string. Of course, we can put here a private, but if the class will be big, we will have it. So this is something that I don't like in type aliases. And do you know why it's not possible to do an extension function only on type alias? Maybe I will ask another question. Do you know what type alias is actually? Just another name. But does it have any equivalent in the bytecode? Yeah. So this is a metadata. So when I will do I will just strip this code off to make it more clear. So when we will see the bytecode and decompile it, as you can see, our class is empty. And what we have here, we have it only in metadata. So you don't have it, actually. It doesn't work, and it cannot work. If the guys from JetBrains would do it, they would probably bundle some kind of check in the plugin, in Kotlin plugin. But bundling such things, the language, and with Kotlin plugin, it's madness. So that's why we don't have them right now, the real type aliases. Good. So who knows about this? Raise your hand. Okay. Less than half. Good. Okay. So we did type aliasing. So we can now talk about reified and inline. So who knows about inline and reified? Okay, and who use it in the production code? A lot of the generic types. What are you doing? Some frameworks? No, I'm joking. Okay, so this is really nice thing in Kotlin, and it's an extension to generics, because in Java, generics are stripped away. In our code, it's only for the compile time, for checking. But here we can do some magic. So we can put a keyword reified at the beginning of our generic type, and then we can check this type. So we can check, like, to be checked is not type of T. In Java, you cannot do it. So if we do this, it doesn't work. We cannot take a type from a generic because this type doesn't exist. So here, a really clever sugar was made by Kotlin guys. And to check it, I will maybe delete it. Try to decompile it. And what we have here, as you can see, well, okay, it was just stupid. I need to invoke this function. Okay, so what we can do, we can have a val name string Peter. And what we can do, we can it will not be a good example, but yeah. Imagine that we have some super type of string. We can do it. Maybe we can do it. It will be any, yeah. So we can do the any, place it any, but here, when we specify it, we are we are string. We see in the breadcrumbs that we are string. So actually this function is giving us an ability to check the type of parameter by placing generics. So it's a casting. So when we will check it in the bytecode, not in the bytecode, but in Java equivalent, you will see nothing. This is the compiler. Because I did nothing in the function, so it was stripped away. So let's do something here. Yeah, so now, as we can see, the code from the block, it's just inlined, so it's passed here, and we have it like this. So it's pretty awesome how they did it, this checking for you, and I really like it. So yeah. So if you would like to do some generic functions and you need the type in the runtime, it's a good way to go. So yeah. And the last thing that I want to show you, it will be pretty nice. I like it. So delegating. So do you know delegating in Kotlin? Yes, you know. Raise your hand, please. Work with me, because I'm shy. Okay, nice. So we have a different type of delegates. We can delegate implementations, we can delegate properties, we can delegate a lot of things. But how to do it in the right way, I will show you. So firstly, we have two definitions of interfaces, navigable and searchable. And inside we have a one property here on navigation click. It's a lambda, a nullable lambda. And we have in the searchable search text. And I did some implementation, navigable imp and searchable imp, the best naming ever. So yeah. And then we want to create a component that is built from the navigable thing and searchable thing. And we want to reuse the implementation that we did there. So how we can do it? Of course, we can just implement those interfaces, and we can like manually delegate them. So we need to type this code. So do you know how to do it in a proper way? By delegate, yeah, but why? But how? Do I need to type a delegate here, or? Okay, you don't want to work with me. Okay, so what we can do, we can actually use a delegation here. So we will not do fields. Now we are supplying this interface by navigable and searchable by searchable. And that's it. So we saved some lines of code, but imagine if you have more interfaces, you will have to do it manually, or if the interface has more fields, more functions, we have to do it for everything. But here, we did it in a clean way. So we have a built-in delegate in Kotlin. So let's decompile, and let's see what compiler does for us. So compiler is doing implementing. We have the field. We have a constructor. We have a function from the interface, and the function from the interface, and we are calling delegating. So the compiler does the same thing that we did before. Probably better than us, because there are some checks. Okay. So delegating. But there is some corner case. So imagine the fact that you do not want to expose those types. You want to build a component on the top of those implementations. Of course, you want to cover them with the interfaces, but you don't want to expose them to the world. Imagine that you are building SDK. So what is the technique to do it? To cover it. We cannot inject them, okay. I will just start coding. So let's say we don't want these interfaces anymore, but we want to expose the functionality. So we will create a new interface. Component, we'll say. And we want to have these functionalities here, so we will just copy and paste it. So we are aggregating everything what is in the protocols. Oh my God, I'm Swift guy on the Android stage. Uh, interfaces. Okay, so now we merge them, so it's fine. But when we want to implement those things, we need to, okay, this is not needed anymore here. So we can just do val and navigable imp. And searchable imp. So what we have to do here, we need to do this manually. So here we need to call navigable or something. Yeah, we need to expose this, and here we need to expose this as well. So searchable search text for get, and for set it's obvious. So do you know how to heal this code to make it better? What can we do here? I heard something. Any ideas how to make it more clean? Okay, so I will show you. I have it. I don't have it here, so I need to code it manually. Okay, so what can we do? We can actually use some cool class. You have to write it. So referenced read-only property that is out of T. In the constructor, it will have a K property. It's a special type of Kotlin. From every instance, you can get this class, and you can get something from it, like I will do here. So I'm passing the K property here, and in the operator get value, because I would like to use delegation, so I'm doing this through the operator mechanism. I'm specifying the get value thing, and I'm doing this like when the get value will be called, just call the get from the K property, because K property lets you get a get function from the property. This is crazy, but you can do it. And for the mutable types, you can do the same. So you can say property, but K mutable property, and you can specify two operators, set and get, because here you can mutate also for vars. So you do the same thing. You get from the property a set function, and you are invoking it here. And then I have a really quick, really simple functions that I'm creating an object and passing the property that is passed in the ref as an argument. So how we can use it? We can actually say, wait, when this function will be called, we can do, I can supply it by ref, and I can do navigable on click. So that's it. I'm saying, if you will call this guy, I don't know how to do it, I don't know how to handle it, but I know the guy that will handle it. And the same here, I can just delete and get and set. I can remove the type, and I can say, okay, delegated by reference to searchable search text. And that's it. So we can make it more clean. And one more time, imagine that you have a lot of things that you need to redelegate. You produce a lot of boilerplate code. So in this example, you can remove this boilerplate. But if you are skilled enough, you can say that this thing is dangerous. Why? Do you know why it's dangerous? So, It's dangerous because it uses reflection under the hood. So you can actually do a really nasty thing in your code by calling delegation, by calling reflection code without knowing about it. So let's decompile this. Probably it will show a really nasty looking code. Component, a lot of things are going on here. But what is important is here. See? Kotlin JVM internal reflection. So if you see this package and you are using it and you don't know about it, probably you can get some performance issue. So you need to check it before you use it. You use it. I personally use it, but for places when we don't call them hundreds of times. But yeah, so have you known about this way to delegate? Raise your hand. Oh, okay. Because it's pretty nasty, or or okay. Yeah, it's not so popular. Okay, so actually we have 4 more minutes, so I will just finish the coding and questions. This is everything from my side. Do you have any questions? Yes?
Yeah, so my question is related to type aliases. I don't know if you managed to saw the release notes for Kotlin 1.3, and I was wondering what's your point of view regarding inline classes that should like solve some of the issues?
Yes. So mainly, yes, they are trying. The Kotlin 1.3 will be released soon. It should be on Monday, but it's not. So we are waiting for this. But inline classes, it's a new concept in the language, and it will solve some problems of type aliases. But I don't know how they will work in production, so I cannot say anything. But for sure, if you are looking for answers to the lack of things in type aliasing, you need to dig into the inline classes. This is what I can say for this. But yeah, this is actually the question and an answer, because you answered your question. Yeah. Yeah.
If I use the structuring and then change order of parameters, do I also have to change the usages?
Yes. Okay. Bam! Drop the mic. No, yes, you have to do it, and yeah, but yeah, you have to do it for your own. You will be lonely in your code base doing this. Yeah. Any more questions? If not, I will be here. If you want to talk about Kotlin, I have a T-shirt. Okay, thank you. Thank you very much for having me.